Okay, so do you guys see my screen? Am I audible?
Yes, Sagar, we see.
Okay, so
We can hear.
sorry for the delay. Actually, it took some time for the Dropbox to sync the document. Okay, so it I have to pull the document from another machine, so it took 5 minutes for that. Okay, so let's begin with the class today. So let me walk through this document. So we have covered all those things, and we covered local area network. We covered wide area network. All these optical fibers, the LAN segment, how are we connected, the WAN segments, the Ethernet cables that is used for LAN, and the optical fiber that is used for WAN connection. Okay, and I was about to start with network component for the day. Well, so what are contributing for network components? Okay, it can be so let me write few network components that is used in the in enterprise level. Okay, so like we have a Cisco router, we have Cisco switch, we got firewalls, we have users who make use of laptops, computers. Okay, along with this we also deal with servers, we have storage devices. What else? We have wireless devices. So basically we see all these components within enterprises or an office, right? So these are all relevant. So what comes under networking? So under networking we will be checking out about the router, switches, firewalls, and little bit on the wireless. Okay, the rest of things are not a networking components. You just need to know from the functional point of view what exactly servers does and what exactly storage does. Okay, they have a dedicated team for that. So we have a server team who will handle all the servers. Similar way we have storage team who will handle all the storage device. Okay, similar way for a laptop and computer related issue, we have all the IT admin folks who will help us to set up the laptop, all those things. Okay, so as a network engineer we will be focusing on a router, switch, firewalls, and wireless unit. Okay, so let me show you how these device looks like. So how basically a switch looks like, how is it placed. Guys, be on mute. Okay, so I'm going to show you what is a functional property of a switch, where is it used, what are the switch port, how the switching happens within the switches, and then how switch forwards that to a router, and what happens within router, and how does it it normally goes to your internet. Okay, so let me just draw one simple diagram of an office or an enterprise. Okay, so let's say I have multiple users sitting in front of computers. So these are my users who are laptop users. So let's say this is a user from sales team, let's say this is a user from a marketing team. Let's give these two to some of the IT folks. Okay, IT team. Now these multiple computers are connected to a switch, a Cisco switch, something like this. Okay, so switch has switch ports, and we see all these users are connected on these switch ports. Okay, now this switch port in return, I mean this switch will in return will be connected to a router, and a router will also have a switch port, and the outgoing switch port will be connected to internet service provider. So what are the examples of internet service provider? Let's say AT&T, Vodafone, Airtel, Verizon, right? There are multiple service providers. So this is how a normal LAN connection look like. Okay, so multiple users connected to a Cisco switch, and then it connects to a router, Cisco router, and the router is going to connect to a ISP provider. Now we need to understand the difference between a switch and a router. Okay, I cannot connect multiple users to a router, or neither I can connect a switch directly to an ISP. They work on a different concept. Okay, the functions inside these devices, inside these hardware devices, is different. Like, say for example, when you talk about a normal television, okay, and when you talk about some radios, FM or AM, are they not different entertaining devices? Though you use these for some entertainment purpose, but they too are a different type of um, devices or different type of hardwares, right? Similar way, a Cisco switch and a Cisco router are two different devices. The inbuilt mechanism is different on both of them, so you cannot cross connect them. Okay, you cannot bring router over here, and similar way you cannot bring a switch over here. Now, a simple or a very easiest point to remember would be all your end devices. What are your end devices? Examples for your end devices: let's say PC, laptop, servers, wireless access point, printers, any Xerox machine, any IP capable devices are always connected to a Cisco switch. So this is something which you have to remember, especially the beginners or the one who just joined as a fresher to this batch. Okay, you must remember a Cisco switch is an hardware which connects to all the end devices. End devices are one of these. Now Cisco switch. Okay, now let's say there is one user and he wants to browse Google. Let's say Google is over here. Okay, and as a user, his data will be sent to the switch. Switch will send that data to this port, and this port will be taken to a router, and router will go to the ISP cloud, and then ISP will take to the Google server. Similar way, the return traffic will come in the similar direction. This is how your traffic will come back, and the user is browsing google.com. Okay, so it's to the switch to router, and router to ISP cloud. So just remember this entire diagram, because in the later on slides the topics are little bit advanced. Okay, where I'm going to discuss what happens when the first data was received here. What is switch going to do? What is a TCAM? What is a CAM table? What is a ASIC within this hardware devices? Okay, also I'm going to show a little bit on this external switch port, like what are switch port we can see on a switch, what are kind of ports we see. Okay, what is a supervisor engine within a switch. Similar way, we will also see the overview of a router, how a router look like, what is the internal component of router. So those are some advanced thing, but for someone who joined today, you guys must know this diagram. Okay, so whenever you go to an office, let's say you just got hired to a company XYZ, you go to the first day, they assign you some computer, and you try to browse google.com, or let's say you want to download your resume on the day number one. So you basically go to gmail.com, you will log in and download it, and then you will send to the printer, take this, right? So how is your laptop or how is your computer connected to the ISP, or how are you able to download your resume? Okay, so basically your data will be sent to this Cisco switch. Cisco switch will forward that to a router, and the router will take it to the cloud in the sense internet provider, and then that internet service provider will be connected to another service provider. It will be again connected to multiple service provider, and then it will finally reach to the Google or your Gmail server, and the return traffic will again follow back. Okay, so this is a simple thing which you need to remember, which will be used in the next slides. Okay, so let's say this is a office setup with multiple computers with multiple ethernet cables. Okay, like here there are multiple switches, and then these switches will be taken to a router, and the router will be taken to the internet service provider. So this is how the network flow of a enterprise or of a office looks like. Okay, now what is your Cisco device, or what is your switch capable of? Okay, I'm talking about Cisco switch. So your Cisco switch will connect to multiple end devices like a Wi-Fi modem, a laptop. Okay, it has all your TV unit. It has your CCTV, IP phones, the TV monitors, desktop. Okay, so these are your some end devices which is connected to an Cisco device or Cisco switch. Okay, so let me first start with Cisco switch because this is the basic, or it I can say it's the building block of a networking components. Okay, why do I say that? Because let's say this is an office or an enterprise. Okay, when I have all the end users, so where are these end users connected to? They are connected to a Cisco switch. Okay, they are all connected via Ethernet cables to a Cisco switch, and then Cisco switch is connecting to a router, and then router goes to your outside internet service provider. So we will first see about Cisco switch, then we will see about router. Okay, so let's start with Cisco switch. That's a basic thing for us. Okay, so if you see this diagram, there are multiple components. Okay, so what are these? So basically this is a USB drive. Let's say this device got failed. One fine day this device got failed. Now you can insert the USB drive, you can have that operating system in that USB drive, and you can boot it up. So that is why USB option is given. Now what are these called? If you see this, they are called as switch port. Why is switch port used? Let's say I have computers, multiple computers, end devices. So these end devices are connected to respective switch ports. Okay, these these switch ports can be labeled as per the technology of these switch ports. Okay, so what are the technologies, or what are the switch port labeled as? So we can see it with Ethernet technology. After few years of advancement, we started seeing something called as fast Ethernet, and nowadays we see Giga Ethernet ports. Okay, so this was pretty older in 1980s, which supported only 2 Mbps speed or 10 Mbps speed. Okay, so each switch port during 1980s used to support only 2 Mbps and 10 Mbps. Okay, later after 10 years they launched fast Ethernet, which was supporting 100 Mbps. Okay, later on these Cisco devices came up with the latest version, the latest advanced version, where each switch port was able to support 100 Mbps of speed. So each switch port was able to support 100 Mbps. Now what happened, once user increased, there were so many users using the internet. Okay, the speed also was meant to be increased, because fast Ethernet was started facing issues when compared to dealing with 10,000s of traffic, or in a traffic in a lakhs or a 10 lakhs. Okay, so that is why we introduced something called we introduced Giga Ethernet, which is 1 Gbps or 10 Gbps speed. Okay, the latest devices, the latest switches come with 1 gigabits per second speed or 10 gigabits per second. So from 1980s to 2020, we have seen a drastic change in the technology from Ethernet technology to giga ethernet technology. Okay, nowadays we also have 10 giga ethernet and a lot of other advancement, but let's keep it to the broader range, ethernet to giga ethernet. Also, I was talking about the cables, RJ5 cables. Okay, so it started with cat 1 and now we have till cat 10, but what we use in the production is cat 6, cat 6a, cat 6e. Okay, few years back you might have seen cat 5, cat 5e. So as the interface progressed, as these switch port were advanced, the cable also got advanced. Okay, otherwise it doesn't make sense. You have very good switch port, but your cables are made of or consist of a older technology, right? So something should be compatible. So basically the cables and the switch port must be of compatible speed, then only you can uh, make use of the complete bandwidth. Otherwise it's the lowest one will be picked up. So let's say for example this is supporting 1 gigabits per second, but the cable that you have connected from here to your computer, this cable is supporting only 2 mbps. Okay, now this user is going to get only 2 mbps, he's not going to get 1 gigabits per second, because your cable is supporting only 2 mbps of data transfer. So this user is only getting 2 mbps. So that is why as the advancement happened for switch port, even the cables launched were advanced. Okay, they were able to carry multiple packet or the datas were sent in a multiple ratios. Okay, so this is just an overview of a switch. So let's go to the next slide. Okay, now regarding these kind of numbers, so this is 3750. Okay, where do I see? If you read this carefully, I know this is little bit blurred, but if you open up or if you go and open up any hardware device, so basically there will be a label put up. Okay, so this is a 3750. Now you might be wondering on what basis the Cisco decides this number. So basically we can see something starting from 1000 series till our 9000 series. Okay, so we can call this as 3000 series. So 3750 is falling under this family. So okay, there are even in hundreds, there are some 800 and 900 routers also. Okay, these are very outdated routers, but yes, from hundreds to 9k family we have multiple devices. Okay, there is no fixed range like your 1xx or 2xx or even 3xs belongs to only switch or something like that. Okay, you can also find a switch which is having 6500, or you can also see the nexus family switches which comes with 9000 series. Okay, so there is no fixed in terms of the numbers. Only way you can get to know is go to the Cisco website, enter the model number. So let's say I have 3750 and I want to know whether it's a switch or it's a router. Okay, and this device is not in front of you. So let's only left out option is go to cisco.com, open up the data sheet for 3750 and read all the properties of the hardware. Okay, it will clearly tell you what it supports, whether it's a router, whether it's a uh, switch. Okay, so regarding to this, the reason why I included this box is because in my next slide I have something for these devices. Okay, so this is again the representation of a complete hardware. So these are the switch port. As I told you, they come in various technology: ethernet, fast ethernet, giga ethernet. Okay, so some boxes we will still see which are using in ethernet, even though that's out of the market. The reason they are still kept is your enterprise or your company is not ready for migration. Okay, so we will still see in some government based offices where they are still using the oldest technology, that is Ethernet technology. Okay, so as I told you, these are called as switch port, okay, which is connected to different end devices like computers, access point, servers, storage unit, okay, and one of them will also take to the upstream. We call this, whenever the link goes on a up direction, we call it as upstream devices. Okay, so here let's say upstream devices is one of the router, and the router is then connecting to the internet cloud. Okay, so regarding to the switch, we have a USB option. What are these now? These are called as SFP modules. Okay, why is SFP modules used? Let's say I am getting a connection over on optical fiber. Now I cannot make use of optical fiber here because these are a standard port for the Ethernet cables only. The optical fibers have a different kind of ports. So let me show you what kind of ports I'm talking about. So these are the optical fiber ports. So if you see this and if you compare with the Ethernet ports, they are two different things, right? But yes, we get a converter. That is what is over here. These are converters. If I have a optical fiber, I can place it here and then I can make use of optical fibers. And I have some management port here, Ethernet management port for taking telnet or SSH. I have a console port. So let's say when I buy this switch, brand new switch, there will be nothing configured here. So I can connect the console port with my computer. I can set few things like I can set the management port, I can set telnet and SSH and give it to the remote engineer, and the remote engineer will configure this box. Okay. So as a field engineer, he will make use of this console port. He will connect to his laptop, he will assign a common network between the system and between the switch, and then he will assign management interface IP. He will assign telnet and SSH transport layer. He will mail those information to the remote engineer, and then remote engineer will configure each interface. He will configure interface settings like what should be the duplex settings, what is the speed settings, what is the VLAN that has to be configured. We discussed about VLAN in the last class, right? If you're dividing a complete LAN into multiple broadcast domain, so we make use of different LAN. Why do we make use of a VLAN? We make use of a VLAN so that we don't encounter collisions, we don't encounter congestion in a LAN network. Okay, because when we have multiple computers, something like this, when we have multiple computers like this, let's say they are all placed in a single VLAN. Okay, let's say they are all placed in VLAN 1. Now what happens is, even if one user is sending some information to the second user, okay, all others are going to get flooded. Okay, this is a default behavior in LAN segment. So this is your this is a property of the Cisco switch. What is a Cisco switch going to do? It is going to do a endless broadcast. Okay, to avoid that, I can group them in one VLAN. I can say they are part of one VLAN, and I'll create them. I'll place these two in different VLAN. Similar way, I'll place these two in different VLAN, and so on. Now, whatever information or whatever communication that this user is doing with the second user, it's going to be only between them. The other VLAN are not going to get notified. So what happens is your congestion is reduced in your network. The congestion is reduced, right? It's between two of them. There is no unwanted packets going here and there. There is no collision happening. There is no collision. What is collision? let's say I have one computer. Okay, let me make use of a different color. Let me say I have one computer, I have second computer, I have third computer, and all these are connected to a switch. Okay, now computer 1 is sending some data on this shared medium. Similar way, computer 2 also starts sending some information to computer A. Now when this data reaches over here, the same data, the data from the other side will reach over here. They will collide. Okay, and they will collide, and a collision signal is sent back saying that we encountered collision, packet got dropped. Now they have to resend them. This is this is happening in the ethernet medium. Okay, that is why we make use of the VLAN, so that this kind of collision doesn't happen. Now it's between only two people, right? Other people are not interacting, or they are not even notified, so they are good with their own communications, right? So these are some things which happens in LAN, and we have to take care of these things. That is why we divide them. We segregate a office setup into multiple virtual LAN, virtual local area networks. Okay, so regarding the switching, let's go to the next device. So let me tell you, there are normally two types of switches we see. One is called as standalone switches, and second one is called as multi-layered switches. Okay, let me make use of some notes. Okay, so before we start with switching, we must know what are the two types of switches. One switch is your normal switch, okay, which is a normal standalone switch, which does the work of normal connecting with different end devices. Okay, second type of switch is called as multi-layered switch. In short form, we also call it as MLS. Now, this switch, the first one, is capable of only doing switching, only switching technology. Now, multi-layered switch can do two functionality. One is switching, the second one is called as routing. Okay, one single device, a switch, can operate on two different layers. Okay, so if you guys know about OSI model, open system interconnect, this is a theoretical approach to define the data flow from a sender point of view to a receiver point of. Okay, so let's say if someone over on point A is sending some file, or he's sending an email, or he's sending a WhatsApp message, so he is a sender. The person who receives it is on a point B. Now, as per theoretical approach, we have 7 layers. We have 7 layers under OSI: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Okay, so these 7 layers are also present on the destination side of, or the receiver side. Okay, now your Cisco switch operates on this layer, and we normally call it as a layer 2. So in future, if I call a switch as a layer 2 or a layer 2 device, don't be surprised. It's nothing but it's referring to the OSI layer. Okay, and now router is called as layer 3. Why? Because routers are placed on this layer, which is referred as layer 3. This is referred as layer 7. Okay, so if you start from layer 1 and if you go till layer 7, so that is where your network layer and data link layer are being situated, and we label them as layer 3 and layer 2. Okay, and this is just a theoretical model. The practical model is always referred to as TCP IP. Okay, fine. So regards to the operating of these switches, you will see two type of switches in your enterprise. One switch which is only able, the switch which is just used to connect multiple end devices like computers, printers, all those things. Okay, it's working on a layer 2 technology. We also have some switches which are acting as a multi-layered switch, which is capable of both switching and routing. Okay, which operates on both the layer 2 and layer 3. So this was little bit on the switching side. Give me a second, just a minute. Guys, 1 second, just a minute. Okay. Okay, sorry about it. Actually, I got some student asking for the meeting ID. Well, okay. So regards to the switching, let's just proceed. Okay. So switch operates on layer 2, but yes, if you see or someone ask you, do you know what is a layer 3 switch? Don't be surprised. We also have a layer working. We also have a switch which works on a multi layers. Okay, layer 2 plus layer 3. So that is why my next slide is about multi-layered switch. Okay, so if you see the switch looks very bulky, and there are a lot of components. But when we just check the previous switch, it was just a single standalone box, right? So we only have one set of standalone switch port. We have some set of fan. These are fan, okay, which act as a coolant. We have a very limited console port. We have very limited all the upstream link, all those things. Okay, now uh, these are some basic switches. If something goes here, let's say by some one fine day, this particular switch port goes corrupt. Okay, or let's say one of the fan is down. Now this box is equivalent as non replaceable. That means you cannot do anything on these faulty units. You have to send this complete box to Cisco RMA team. Okay, there is a team called RMA team which will replace the entire box, and then they will send you a brand new box. And now you have to configure whatever the content of this faulty box into the brand new box. Okay, that is a challenge that is faced when we have these kind of standalone box. But when we see some advanced switches, okay, when we talk about these kind of switches, they have redundancy. Okay, so like in our previous model where I had only one set of non-pluggable or non-removable fans, over here I have multiple of them. Okay, so see, if you see here, I have two power supply unit. Okay, these are called as power supply unit. If one goes faulty, I can remove it out. They are known as hot swappable. Okay, I can just remove this, plug the new one. That's all. I don't have to deal with any configuration changes. I don't have to spend money on my field engineer to go to the data center and replace the box, do the cabling, all those things. He will just go with the fresh unit of this PSU. He will take the faulty one, he will plug it, he will notify you, you will do the analysis from your side, and yes, that's all. Okay. And what else we can see here? So I have written some points here. We have totally 4 into fan supply. If one goes down, we still have 3. And even if that one goes down, that is hot swappables. Engineer can come, remove that, and plug the new one. Okay. It has 2 soup engines. Soup engines are called also as supervisor engine. Okay. Supervisor engine. It is acting as a brain of a mesh of this device. Okay. Everything, see, some, let's say some traffic just entered, and now that traffic has to go out. Who is going to decide? It's your soup engine that is going to decide. That is a brain. Okay. Whereas in your previous condition, in your previous devices, these kind of devices, there is no soup engine. Okay. Every decision is made by this hardware, the motherboard that is within this switch, that is making all the decision. If something is coming up and if something has to go out, so basically all the decision will be made by the hardware or the motherboard. But on a higher end devices, we have things separated. Okay. If the data is coming, it's not required that data should be or the data movement should be decided by these switchboard. It will be sent to the soup engine, and the soup engine will make the decision. How should I send this to different or the next person? Okay. So we'll talk about this soup engine, don't worry. And the line cards. What are line cards? Line cards are your switchboard. In our previous case, I only had one line card or one set of switchboard. Over here we will see multiple of them. Okay. So it is supporting 6 line card. Even if one goes faulty, we can remove that, we can plug it. Okay. So that's an advantage of these devices. Now you might be thinking, why do we need different set of devices? Why don't we use only 45 everywhere, right? So let me tell you, if you talk about pricing factor, that matters a lot for a uh, design point of view. Okay. This simple box will cost you like 5,000 US dollars, and the one which I showed you previously, it will cost you like 400 US dollars. Now why will your company spend 5,000 US dollar when they can do the same thing on a lower price, right? So pricing is very important. When we talk about the network or a company design, it's all about pricing. It's not about what device you are going to use, what technology you are going to use. It's all about pricing. Okay. Pricing and the performance that you're going to get for that pricing. Okay. So why do we use these multi layered switches? Okay. Let's say I have very startup company. Okay. Who will have some standalone switches, Cisco switches, which are used to connect multiple users or access point or printers. Okay. And then these switches will be connected to a multi-layered switch like 4500. Okay. Since I told you this multi-layered switch can do the both the work of L2 and L3, that means this switch can also be connected to a ISP. Now I don't have any router required in this case. Okay. So this kind of network designs will be seen on a startup companies or a small scale industries. Okay. With like thousands of employees or within thousand, like 500 of employees, when they don't want to invest on a separate layer 3 devices. Okay. Because these can do both the job, layer 2 and layer 3 job. Okay. So that was regards to the pricing. Sorry.
Yes, Sagar, I have one doubt.
Okay.
So in the 4500 series router switches, how many ports will be the LAN ports?
It will depend on the pricing. Once again, it will start with 8 and it can go up to 48, or you can also imagine 48 into 2 or 48 into 3, or you can. So it depends on the pricing.
Okay. Okay, thank you.
Okay, I'll show you one more interesting thing. Okay, you guys can also download this software from internet. It's called a Cisco CX product. Okay, if I click on the product catalog, if I go to the switches, if I go to catalyst switches, I can see multiple switches, multiple types of switches. So this was the first switch which I just showed you. It is just a basic switch which is used to connect multiple end users like computers, all those things. Okay, how do we connect? So we will have the RJ5, RJ45 cables, Ethernet cables, and from every switch port we can connect to a computer. Okay, so let's say we have multiple computer users. So let's say these are all computer users. Okay, this is a very basic thing which is used only for connecting end devices, and we normally place them, or we also call it as access layer switches or only access switches. I'll tell you what are the access switches, what are distribution switches, and what is the core switches in the next upcoming classes. But for now, you just understand what are all the names I have made use of. I made use of layer 2 from the OSI point of view. I'm calling access switch from the point of topology hierarchy. Okay, I also made use of layer 2 switch and multi-layered switches. This due to the operational level of point of view. From the operation point of view, I can call it as layer 2 and layer 3. So these are some terminology that I used in the switching platform. Okay, so these are something which you also have to remember, because during interview they can call it as access switch, they can call it as a layer 2 switch, they can call it as a standalone switch. So don't get confused, they all mean the same thing. Okay, fine. So this was a basic switch with the basic connection. Now let me show you some advanced switches which is capable of layer 3 also. Layer 3 and layer 2 at the same time. So let's talk about 4500 switches. Okay, so this is a 4500 switches. This is a bulky switch, 4500 E series. E refers to Ethernet. Okay, these are all the fan which I was talking about. This is a power supply unit. Okay, the one which you see here, there are two power supply units. So let's try to take it out. Okay, that's a power supply unit. So if you see that, that's how we can remove them, and it's called as hot swappable. If one thing goes wrong, we can raise the RMA with the help of Cisco, and we can say this is not working and I need a new power supply unit. So you don't have to change this complete box. You don't have to do anything. You just have to replace one particular power supply unit. That's all. Okay, what else do we see in this kind of devices? We will see supervisors. Okay, so let me show you what is supervisor. I told you this is acting as a brain of this whole machine. Okay, it will decide how to go to the next devices, what is the routing protocol, whom to reach. Okay, so basically all the functionality, all the communication between two different switches or switches to the next router will be all decided over here. It's acting as a supervisor. We call it as a supervisor.
Voice is getting break.
Okay. Are we good? I don't see any latency from my end. So are we good? Do we have any audio disturbance?
Sir, you are just fine.
Okay. Okay. Okay, I'll check the chat item in few minutes. Okay, so after a couple of slides, I'll take Q&A. Okay, I'll give you own time where you can ask me the questions. Okay, so yes, so this is a supervisor, and along with supervisor, along with the brain. So how many supervisor do we have? We have two supervisors. If one goes faulty, we have a redundancy with us. So this is the second supervisor. Similar way, we have line cards. Line cards are all your switch ports. So let me show you what exactly. So this is the line card, okay? And if you just see the description, they are 48 ports. So this was you asked, right? How many ports does multi-layer switch or a 4500 support? So basically it supports 48 port, okay? And we can have 6 different line cards. So you can just imagine how many connections we can give out of these boxes, right? That is why these are also costly. They are used for multi user connection, or it is used in a core layer. Okay, so that's regarding to the multi-layered switches. Let's talk about what happens within these switches. If something comes into the switches, what is expected behavior? Okay, 1 second. So before that, is there any doubt? I mean, still, I'm especially asking the beginners, because someone who is already NA or CCNP or CCI, this might be basic so far. So only from the CCNA point of view, I'm asking. So are we good till switches? We have not started routers yet. This is only the switches, and I have only covered layer 2 switches and multi-layer switches. So are we good? I mean, are you guys able to understand the things? So guys, are we able to? I mean, are we on track? Do you guys are following me? I mean, is there something which I need to repeat or something? Okay, fine. So I take it as clear still here. Okay, the basic differentiation between a switch and a router. And now let's go little depth. Okay, and let's go and see how what happens within a switch. Okay, so let me make use of the diagram, the LAN diagram. So let's say I have a Cisco switch, a normal Cisco switch, which is some model, let's say 3750. The first scenario where I'm using it for connecting multiple computers. So when something has to be communicated between two different computers, so basically what happens is the data will go out of this computer. It will hit the switch port. The Cisco switch will broadcast it. It will broadcast to all the active unit. Now let's say the communication was intended between A and B, not with this computer, not with this user. So this data will be discarded because that is not meant for that, but this will be accepted by this, okay, and the return traffic will be taken back to the user A. So the first traffic, that is A to B, happened on broadcast. Broadcast is nothing but when once some data received on the switch, it will endlessly flood that to every active switch port. It's called as a broadcast. The return traffic went on a unicast. Unicast is one-to-one traffic. Okay, back, because it knows whom to reach back, right? And I'll tell you how this switch learns MAC address. But for now, let's take it as broadcast and unicast. There are two things that happened here. The first, from A to B, it was not aware of where B is located. It just broadcasted to every active switch port. All others are going to discard other than the actual B user. Now B is going to reply back and it knows where is A connected. Okay, so first traffic initiated over broadcast and then response was given on unicast. The internal architecture of a normal or a standalone switch is very simple. Okay, we have a motherboard. Okay, now someone who is not from a computer background, so let me tell you what is a motherboard for a Cisco switch look like. So these are the motherboards. Okay, basically the chips where we can see the memories, storage boxes, storage units. Okay, these are within the Cisco boxes. So those boxes will do the switching decision. So let's say if something was received here, what if someone asks you in very layman's language, what happens inside switch? Let's say some data was received on port A, and now switch has to data to switch that data out of port B. Okay, let's say this is port A, and let's say this is port B. Something came in to a Cisco switch, and the Cisco switch has to send that out, right? So what happened, or what how is Cisco doing the switching? So it's your motherboard which is doing the work of switching. So basically there are three planes to define that. Okay, one is called control plane, management plane, and data planes. So data plane is your normal traffic, that is A to B. Control plane is the brain of the switch. Okay, and the management plane is, let's say this is a network engineer and he wants to configure on this box. So he will do telnet and SSH, and he will take the configuration terminal, he will change the IP address, he will do the configuration. That is management, right? So all the three planes are on a single motherboard. Okay, there is no segregation, there is nothing called three different planes on a basic switches. All the three planes are lying over on a single hardware or a single motherboard unit. But when we talk about a advanced switches like 4500 switches, we can see three different planes. Now the traffic flow within these boxes are very interesting. Okay, so I'll tell you how exactly the traffic enters to these 4500, and how these 4500 will decide whom to send it. Okay, who is the next person to whom this uh, data has to be sent. So this is very important.
The routing services is happening in a plane.
Sorry.
The routing services is happening in a plane, control plane or management plane.
So can you give me some time, because I also have for routing plane. So I'll cover up in that. Okay.
Okay.
Yeah.
Okay, fine. Okay. Thank you.
So when we are talking about Cisco's switches from a switching point of view, so these are the three planes: control planes, management plane, and data planes. Okay, so I'll talk about how data enters to a switch and go out of the switch. What is happening inside the switch is an interesting concept here. Okay, so this is a internal flow of your 4500. Let's say this is a complete 4500 box, which is a multi-layered switch, which is capable of layer 2 switching plus layer 3 routing properties. Okay, and also we know there are three planes: management plane, control plane, and data planes. Okay, usually in most of the scenarios, when let's say on my this switch port, I have a computer connected, computer A, and on this port I have a computer B. Now computer A is sending some packets to computer B. So usually that will be taken over on a data plane. Okay, very simple, it's taken over on a data plane. But there are some scenarios when data plane cannot make that decision. Okay, and we call those packet as a special packets. Okay, now what are the condition for it to be called as a special packets are: the first one is this: let's say if the packet is destined for one of the IP address of a multi-layer switch, let's say the destination is residing on this switch itself. Okay, so let me tell you like this: let's say this is a multi-layer switch. On one interface I have computer, and the second computer is also connected on this. So all two IPs are on the same multi-layer switch. That is the first scenario, when both source and destination are on the same box. Second reason for special IP packets are if there is a routing protocol involved. So when is this routing protocols coming into picture, especially in the routing technology? But since these switches are capable of L2 and L3, So L3 is capable of handling routing. Now in case of routing protocol, your data plane will not make the decision. It will forward that to the control plane. Okay, and in the control plane, it will see the routing information or the routing table where all the learned routes will be placed, and then it will make the decision how to go out. The third option is if there is some option set in the IP header. Okay, now you guys may not know what is IP header. So every IPs or every network layer packet, there will be multiple components. Okay, so I'll tell you this in the upcoming classes. So this is how the IP headers look like. So let's say there is a special information set on this. Now that is also considered as a special IP packet, and your data plane will not be able to pass it on, or it will be not able to switch it directly to the outside interface. It has to go to control plane will check, and then control plane will decide whether to send to the data plane and then go out, or directly from control plane I will select what is the existing interface and then go out. Okay, that is your control plane. That is what I said. One second. Okay guys, be on mute. Okay, so that is what I said in the beginning of the class. Control plane is acting as a brain. Okay, so this is your brain which will decide of how to send or whom to send. And the last factor for a special IP packet is when the TTL is expired. So what is TTL? TTL is called as time to live. Okay, what is time to live? Let's say I have one data packet, I'm sending it from A to B. Inside this packet there will be some component called TTL, and I have to set that. Let's say I'm setting it as 5. Now this will go and hit the first router, it will hit the second router, it will hit the third, fourth, fifth. Okay, and all the TTL gets decremented by -1. At this point your TTL becomes 0, and you will get a message saying that destination not reachable. Okay, so how should I prevent these kind of scenarios? I have to increase the TTL to, let's say, 10, and now it will still go and it will finally reach here. So let's say the total TTL, it took 7 or 8. Okay, but what we had set 100, so our packet reached here. So TTL is time to live from your point A to reach to point B. Okay, in between you can encounter, or you might transit over on multiple routers. So every routers your TTL will be decremented by -1. So that is a TTL. So these are the 4 factors for your incoming packets to be categorized as a special packet. Okay, so as I told you, these are the 3 planes that we see on all the switches, all the switches. Okay, your basic switches will not have these 3. All the 3 will be embedded on one motherboard. But when we talk about the advanced switches like 4500, 6500, the planes are divided: data plane, control plane, and management plane. Take it out management plane, because management plane is with regards to configuring that particular box, or configuring that particular uh, device. Okay, so take it out. It's not related to our data packet flow. Okay, it's something like when a network engineer wants to configure on that box, he will go via management port, he will configure, and he will come out, right? So leave that management plane. So basically management plane is also situated here. Okay, but that is not disturbing us for our normal traffic. So let's say this is my 4500 or a multi-layered switch. Okay, it has multiple switch ports. So this switch port is connected to computer A, and similar way this switch port is connected to computer B. Now this person is sending some file which has to be received on this on B. So his data will enter here. Okay, now what happens is it will first see if I can directly pass it to this, and the data will be taken down. But in some special packet services, or when the special IP packets are being recognized, one of the factors are these: if both of them lies on a similar device. Let's say I have 1.1.1 here, and I have 2.2.2. over here. Now they are on the same device, right? Now in this case, our data plane will not help us. This has to go to control plane. Okay, the traffic will be taken to control plane. Control plane has all the routing protocol information located on the routing tables, and then it will decide whether to go directly from that exiting interface, or send back to the data plane, and then data plane can send use one of the existing plane to reach PCB. Okay, so this is different planes, very very important from the point of network interview or your future troubleshooting. Okay, because this is something which is leading to your SD-WAN. If you know what is SD-WAN, so basically SD-WAN is popular because we can manipulate individual planes, okay, on a WAN side. Now this is regards to your LAN, right? On a LAN box, we can control the traffic. Similar way on a WAN, ISP, Internet Service Provider. Nowadays we are making use of SD-WAN because we can tune this control plane and data plane. So this is a topic which will lead you to all advanced topic in the future. Okay, so don't ignore this. This is something which is basic, as well as it will lead to the advance in future. Okay, fine. So let me go to the next slide. Now I have included this topic for some reason. Okay, so as you know, a normal switch, if something comes in, it will just send it out. Okay, there is no three different planes. There are no concept of a planes. All the three planes are basically on a motherboard. When we have this 4500 switches, a multi-layered switches, we have three different planes. Okay, now you might be wondering, isn't it this 4500 slower than a normal switch? Because the data plane, if data plane can't handle, it will take to the control plane. From control plane, it will come back to data plane, and it will come back to the point B, right? So it looks little complicated. It might look like uh, it's slower, but in fact these are very faster than your the traditional boxes. The reason is, you have a hardware component. These are called as special hardware component. Okay, the full form of ASIC is application specific integrated circuit. So where are these located? This is located in your motherboard. Okay, so these are located in your motherboard. So there is a special hardware called as ASIC. Now this particular hardware consists of two memories. One is called as CAM memory, other one is called as TCAM memory. CAM is for content addressable memory, and TCAM is ternary content address memory. Okay, so with the help of this special hardware, with the help of these two inbuilt memories, our switching is much more faster. Okay, so what is stored inside CAM table? So inside CAM table, we have all the source MAC address. Okay, so let's say I have 4500 here, I have a PC1 here, and I have PC2 connected here. Okay, so in the ASIC hardware, which consists of two memory tables, one is CAM table and one is TCAM table. So CAM table will have all the information of my source. Okay, the source MAC address. What is MAC address? Every hardware will have a physical identification number. Okay, or a physical ID number. So this MAC address will be stored in your CAM table. So it will be stored as source MAC address. What is next thing that is stored? It, where is it associated? It is associated with this interface. Let's say this is FA0/1 0/0. So that information is also going to store in your CAM table. What is the third thing? What is the VLAN that you have configured between this user and this? that information is also going to store on your CAM table. Now it's very, very faster when you compare with your standalone boxes, the traditional boxes. These ASIC are very much faster in switching. Okay. As soon as something comes up, they quickly check the ASIC and they switch the packet. Okay. They will start immediately switching the packets. Similar way, the next table, that is TCAM table, will take care of all other things like your access list, your QoS, and your routing table. Okay, even if your traffic was sent to the control plane, in the control plane, your TCAM will take care of all the routing tables, and your CAM table, all the basic information will be stored in your data plane. Now it's very, very much faster. So this is your internal architecture of a switch. Okay, if someone asks you, let's say on a point, on a port A, I received some data, and this data is going out over on a port B. Now tell me what is happening inside the switch. How is a switching the packet? Make use of the word switching when you define or when you explain a switch. Don't make use of routing anywhere. Okay, routing is a different concept and switching is a different concept. Okay, so inside a switch we have these planes: control plane, data plane, and management plane. So it's your control plane and data plane which is accountable for switching the traffic. Okay, now if someone asks you, isn't it this process going to be time consuming when compared with all your standalone boxes? Now the answer is no, because we have this special hardware called ASIC inserted on these motherboards, which are having two kinds of table. One is CAM table and TCAM table, which is taking care of all the information. Okay, so switching is very much faster. So this is the internal flow of a switch. So any doubt so far here? I mean, is it something which you guys are okay, or you want me to repeat something here? Are we good so far?
Yes, Sagar.
Okay, I hope I'm not going very advanced. Okay, in case if you guys get stuck, please let me know so that I come back to and explain. Okay. Okay, and also I will share these notes after the class. So just go back; things will be very clear. Okay, it sometimes it might look little confusing while hearing all the new terms for the first time, but these are very important topics. So I can't afford missing these topic or not including, thinking you guys might take it in other way. Okay, I have to include this because it's very important and very uh, what do you say, basic things that you should know about a any hardware. Okay, I'm not only talking about a switch. Later on, when I move to a router, you must know what are the internal component that is routing the packets inside router. Similar way, when I'm talking about a ASA firewall, what is happening inside the ASA firewall? So these are normally called as a packet flow. Okay, and as a network engineer, we must know what is the packet flow happening within every devices, like, right? So like what happens within switch, what happens within router, what happens within a ASA firewall. So we just discussed the first one, what is happening inside a switch. Now let's go to some more basics after this slide. So I'll try to cover some more basics here. Okay, like types of switches. Okay, so one type of switch is catalyst switches. This is the software that is loaded inside these switches. Okay, so basically these switches comes with some pre-built iOS. But yes, after few months or after, let's say, 1 year, the same iOS version or same iOS code, let's give an example 16.6.2, they start uh, having lot of vulnerabilities. Vulnerabilities are nothing but weakest point in the code, due to which someone can hack or someone can take the control. Okay, or I can say the weakest point of this iOS. Okay, it's with all the softwares, not just with Cisco. You talk about any software, they will be sending you patches. Even Windows, every year and then we will see some patches being released. That is because they find that there is some loopholes which can cause vulnerability, or that can cause a backdoor, right? So they have to fix that, and they will launch some patch. Similar way in iOS, in a iOS kind of devices, Cisco Catalyst, which is a traditional family. So there are actually three families in Cisco. Okay, one is called iOS, iOS XC, iOS XR. Okay, this is the oldest one when your Cisco was actually launched, and as advancement happened, the newest family is all coming up with preloaded XC family, and all your routers comes with XR. Okay, these are some software families that is loaded on these Cisco boxes. Nowadays, we also have Nexus boxes, which comes with NX OS. Okay, which is called as Nexus, and Nexus are specially placed in the data centers. So these are related to softwares, the software or the software code that is being um, inserted on these boxes. Okay, just having hardware is not going to help. We have to install the rightful software. Something like our laptop, if I have a laptop but if I don't have any Windows operating system, my laptop is not gonna help me. I must have a Windows, I must have a Linux, any operating system, but I must have something so my laptop is fully functional. Similar way, these devices also comes with softwares. Okay, so as I was telling, when I have some pre-installed software, after few months we see that there are a lot of backdoors. Okay, this code is exposed to multiple vulnerabilities. Now Cisco has their own team, developers team, which is working on these patches. In few couple of months we will see something coming up like 6.6.5 now, which has a fix for all these vulnerabilities. After few months we will see something coming up with a different version, something like this, which has few more fixes to the vulnerability that was exposed to this. So that is how the software line works. Okay, so this is one of the basic switches, Catalyst. We call it as Catalyst switches. We have Nexus boxes, which is having the uh, highest throughput. Okay, and because of the highest throughput, we normally keep them in a data center. Now, if you don't know data center, or you don't know what is the difference between a data center and a office, in a few minutes I'll also tell you what a data center looks like. Okay, so basically in a data center, expect traffic from a user like 10,000s of users, and in an office you can just uh, assume traffic from 100 to 200 users. So that is a difference. Okay, data center will have a largest traffic come incoming, outgoing, and whereas in an office it's just like 50 to 100 or 50 to 150. So these are Nexus family, which are kept in the data centers, and these are different models of Nexus family. Let's quickly check other slides. So this is modular switches. Modular switches, the examples for modular switches are 9400, 6500, 6800. So basically you can see multiple supervisor engine. You can see the hot swappable PSU. These boxes also support uh, concepts like stacks. Okay, I'll tell you what is stack, what is VSS. Okay, these are all redundancy technologies in the switching platform. So in the upcoming classes, what I'll do is I'll take one class where I will design a network, or a design a network for a enterprise. Okay, so we will see how to make a decision, how to make a wise decision to take the distribution switches, what type of core we must take, how do we connect the end devices, what is the best practice. Okay, what is stack referring to, what is VSS referring to. So all those things we will do a design work or a design lab where we can come to know the orientation of these devices. The placement of devices is also important factor. Okay, let's say if someone has given you switch, some routers, some firewalls, and they ask you to build a network. Now, if you know what is what, but you don't know how to orient them or how to place them, or you do not know what is the placement of these devices, then there is no point knowing the devices point of view, right? So you must know how are these devices are connected, which comes first, which comes second, which comes third, which is connected to ISP, which is connected to end devices, right? So for that, I'll do one design class or a design topic where I will show you taking up these devices, plugging it with the help of cables, uh, making some configurations, the best practice that we follow. Okay. Okay, so let's go to next slide. I have some fixed switches. So basically, these are industrial used switches. They can be exposed to extreme temperature. So these are special devices which is used in industrial purpose. Okay, like Catalyst 2K 93, 1110. So these are called as industrial services or industrial switches. They have a high resisting powers. Okay, these are the stackable switches which I was talking about. Okay, so one best example is 3750. Now, what happens in 3750 is, let's say I have one 3750. Okay, something comes in and something goes out. So that is a default behavior. But when I have a stack, out of four devices, one is going to be the master, and rest are going to be the slave. Okay, and this is the cable orientation. The one comes over here, the second one goes somewhere here, and from this we get it here, and so on. We just interconnect them. Now all the rest are slave, this is master. That means your control plane, your brain, is going to be. So is there any lag, any voice lag? I saw someone coming out of mute. I hope there is no lag somewhere. Okay, I let me see. There are some pop-ups over here. Okay, so I'll take this after some time. I don't see any urgently asked questions. Okay, I'll take after some time. So this master act as your control plane, and rest are your all data planes. Now something comes to these data planes. This is going to take the decision how or where to switch the traffic. Okay, and as a point of this guy, let's say there is a user over here, and a user is connected to one of the switchboard. He will not come to know that he has been connected to something this kind of connection. He will not come to know that he is connected to a technology where four devices are in a stack concept. Okay, he will just see this entire box to be as one switch. Okay, and this box is then over on upstream has a router connected, and a router will also take this as a single box only. Okay, it's only these switches which know who is slave, who is master, what is the decision happening, or what is happening inside this. Okay, so this topic along with the next VSS topic I'll cover up in the upcoming classes, because I will not be able to cover all this in one single classes. Okay, so who is not in mute? Okay, so these were stackable devices, and once again, all your switches are not capable of stackable. Okay, that was the point I got this slide. All your basic switches, which is costing $400 or $300, they are not capable of stackable. Stackable is a special uh, features of a device. So only some uh, popular devices like 3750 or 9300, they are capable of stackable. So how do we come to know whether a switch is stackable or not? Go to Cisco website, open the data sheet, and there you go. You will come to know whether it supports stackable, whether it's a standalone box, what is the throughput of each individual switch port. Okay, so that is how it going to look like. Okay, fine. Okay, so this ends your switching part, and before I start off with router or a routing technology, do anyone of you have any doubts with respect to switch or a switching, whatever we just covered up today?
There are a few questions in chat.
Yeah. I'm going to that. Okay, so we don't have Nexus here. Okay, Nexus is a data center switch, so it comes under CCNP data center, not in the enterprise. Okay, yeah, there are Nexus 3K also. So basically, we have Nexus 9K, 7K, 5K, 3K, 2K. Okay, uh, so these are all the core or distribution layer switches, and this is a access layer switches which connects to the access or end devices. No, we are not building on Nexus. Okay, we are enterprise engineers, which are the routers and switches, irrespective of Nexus. But yes, you can build on Nexus. But thing is, you must also have necessary resources. Your Nexus box will take like 4 GB or might be 8 GB. Your Nexus 7K and 5K. I'm not sure about 9K. It takes up to 8 GB. One single box will take up to 8 GB. Yes, 9K, 2K. Okay, 2K is called as FEX. 2K is a brainless device. Okay, it doesn't have any operating system. So it's the 5K which will operate, or that is that's 5K is something where you will push the software to 2K. Okay, 2K are like a standalone block or unmanaged devices. Okay, I'll get this chef table, like all the important tables in the upcoming classes. I hope you guys are clear with the cam table and tcam table as of now. Okay, so if you don't have a redundancy in your network, basically then you can connect two boxes. This forms the redundancy. Let's say switch A and switch B. If something goes down, you have okay. Let me draw some users. Okay, let's say if this goes down, so you have still this box which is acting as a redundancy. Now stackable is not only about redundancy, it's about the throughput also. Okay, so let's say I have stackable boxes which are in this way, a single box. Okay, so all are connected here. So no matter one goes down, it will still switch the packets because you are having the concept of master and slave, and all these switches are interconnected. Okay, so don't have to worry about losing one of the device or something. So we'll learn more on this. Okay, don't worry about that. It's a part of CCNP.
Sagar, I have one doubt.
Okay.
In stackable switches, if the master is failed, okay, the slave switches goes to master.
Sorry.
We have the stackable switches.
Yeah.
Okay. So if the master switches goes to fail,
okay. So
Then what will happen?
so if master goes down, we set them priorities. Okay, how do you think, out of four or three switches, how do you think one of them gets the master designation? It's because of the priority that we set. Yeah.
Priority, yes.
So if this goes down, there will be next or the fallback, and then that becomes the master.
Okay, fine. Okay, thank you.
Okay. Okay, cool. And okay, so what is the time to 12? Okay. Let me see if I can cover routing at least. Okay, so let's cover routing, and in the next class I will talk about the packet flow inside ASIC firewall. Are we good, or anyone getting late for the day? Are we good to carry on with routing, or what happens within the routing, or if packet flow inside router? Okay.
Yes.
Okay. The no says yes now. Okay. Well, so let's talk about router. I will show different types of router families, or different types of versions of router. For today, I'll only talk about the packet flow happening inside router. Okay. So let's say I have a router which consists of multiple switch ports. Something comes in. Let's say this is the in. Okay. Someone is not on a mute. Okay. So some packets just entered, and then it has to go out. Okay, it can be to a different network, it can be a ISP, it can be to different network in the same LAN connection, it can be anything. Okay, router is used to connect two different networks. Let's say network of 1.1.1 with networks of 2.2.2. Okay, and how does it do? It will have a routing table. Okay, a software based routing table which will keep all the records of networks. So let's say 1.1.1 is on this switch port, network.2.2.2 is on this switch port. It will also make the entry to reach 2.2.2. It has to go via so and so port. So if something comes for 2.2.2, routing table will see its database. It will say to reach 2.2.2, go via fast ethernet 0/1, and then the packet will be sent on the destination. So that is the properties of a router. But if someone asks you in the interview, you must give the complete steps. Okay, so it consists of four steps. First step is input, the port which you receive the packet. Let's say this is the input packet, and then something happens on a switching fabric, your routing information, or routing tables, and then the outgoing ports. Let's say this is F03. Okay, so there are four steps happening within the router. So let's see what is switching fabric and what is routing processor. So when I talk about switching fabric, this is something which is been hit first. Okay, your routing table comes in the second part. So once some packet gets inside, it's your switching fabric that takes this. Okay, so what happens is router receives a packet on the first input. Now let's say it will start validating that packet, and it has to decide on some circumstances. So how does router make the decision of forwarding? It will see three criterias. The first criteria is longest match. Second criteria is administrative distance, and third criteria is cost. Okay, if first one holds good, it will make the decision with this. If this is a tiebreaker, then it has to go with administrative distance. Now if this is also a tiebreaker, then it has to go with cost. So it will first check these three factors. Okay, so while doing the three factors, it comes to know that the outgoing packet is on the locally connected interface. You might have seen the routers will have two locally connected interface. Let's say 1.1.1 on this side and 2.2 on this side. There is no requirement of any OSPF or BGP or anything. They are shown as local or directly connected routes, or sometimes you have some static routes. Now these are coming under your switching fabric. It is not reaching, or it's not going till your routing table. It don't have to depend on OSPF route or your BGP route. So depending upon your directly connected or directly connected or local connected or static, it will send the packets straight away to the outgoing direction, and that is how your switching fabrics come into play. Now let's say this traffic which just came in, it's not falling under any of this criteria. Let's say the destination is not on the same router, it's somewhere out. Let's say it is on this, and from there it is going somewhere else. Now they are not in on the same router. Okay, now your switching fabric cannot make the decision. Now the traffic has to be sent to routing processor. Okay, like this. If you see here, now it's not in the now it's not under the control of switching fabric. It will send to the routing processor. Routing processor consists of all the route learned via OSPF, EIGRP, BGP. Okay, all other protocols, and then this will decide how to go out. So it will basically send back to switching fabric, and switching fabric will make the rightful decision to go out. Now if something is not over here, then the router will straight away drop that packet. Okay, if the whole router doesn't know where is the destination network, it's going to drop. Okay, so in order to avoid such drop, we normally define some default gateway. So if something comes which is not part of switching fabric or not part of routing processor, and at the same time I don't want to drop it, I will make use of default gateway, and I will say that all such unknown traffic go to so and so. Let's say 10.10.10.10. Let's say this is the next router. So all the unknown traffic will be sent to this router, and then this router will make the decision. Again, the same thing happens switching fabric and routing processor, and then it is going to decide whether to drop or whether that interface is known to this particular router. Okay, so this is happening in case of routers. So for someone who just joined for the first time to this, so let me tell you in very layman's language. For a switch and for a router, let's say I have a switch here. Okay, no matter it's a layer 2 switch or it's a layer 2 plus layer 3 switch, I have a computer connected here. So basically they will be in the same network, or they can be in a different network. Let's say it is a part of VLAN 1 and this is a part of VLAN 2. Okay, in this case we have a concept of inter VLAN where we need a layer 3 devices. Okay, and then the traffic will go to this, the routing table is checked, and this will be pointed to this. Now let's say there is no inter VLAN concept. Let's say both of them are inside single VLAN 1. In this case, both of them will be having a same network IP. So the data will go to switch, and switch will send immediately to this. So my point is, this will have 192.168.1.1 and this will have 192.168.1.2. So you can see this kind of network IPs designated on a switching side. Okay, but on a router side, router will not have two same network. Okay, at any cost, router will not have two same network. Let's say I have multiple switch port. So each switch port will have different networks. So let's say this is a part of 192.168.1.0. Now I cannot have this network in 1.0. I have to make use of a different network. This is 2.2.2.2. This is 3.3.3.3.3. So this is a main difference between a switch and a router Okay, so this is one more difference. On a switch, you will see computers connected, belonging to the same broadcast domain or a same network. But in a router, you cannot have the same network. You all are different networks. So that is why the basic definition of a router is router connects multiple, or router interconnects multiple networks. So this is one network, this is one network, this is, these are all different networks. So that is the work of a router, to interconnect different networks. Okay, whereas the definition of a switch is to interconnect or to connect multiple end devices. I can have multiple printers and all those things. Okay, so are we good so far? Is there any doubt before I wind up for the day? I hope you guys are enjoying the class and not facing any difficulty to understand anything. Okay, great to see. Great to know that people are all understood. Okay, if there is something which you don't uh, are not clear with something, so you can just put up over here on the screen, or you can just unmute yourself and you can ask on the call. Okay. Okay, guys. So let's meet up in the next class. Okay. I have few more slides here where I'll be covering all the different types of routers, different type of tables, designing a network, concept of stack, VSS, okay, and different type of topologies like spine leaf, two-tier architecture, three-tier architecture. All those things will be covered up. Okay, so yes, some of the guys have already taken up the lab. Okay, we have already set up the lab, so those who have already enrolled have got the lab, and I heard 2 3 students are able to practice. If there is something missing, we will set it up in next few days, so don't worry about getting it done on just on the first day. Okay, so we are not using lab at least for next 2 3 days, because I believe we need 2 3 days to set this up on everyone's laptop, right? So it will take 2 3 days of time when we set this up. I have pinged everyone on individual note. Everyone, I have shared the Google Drive. I have shared the GNS. So I expect you download this and keep it ready. And our lab trainer, so he will come. He will set this up, and then you guys are ready with your own setup on your laptops. Okay. So cool. Are we good to wind up?
Hello.
Hello.
Yeah, Vaisagan, you have the lab for the EV.
See, the problem with EVNG is, I want to be very honest. I started up with Eve. Okay, I'll just show you.
Okay.
But what happened is, some point I got stuck. I'm not sure whether I got stuck, or might be that's the way EVNG is. Okay, so let me just show you what is my point. So maybe if one of you knows, you can just guide me so that I can recreate this on EVNG, because my preference was EVNG when I started up, but then due to some issues I was not able to. Give me a second.
Sure.
Okay, so this is my EVNG 192.32.129. So let me quickly log in here. So if you see, this is my topology that I started up. Okay, but then I'll tell you where I was stuck. I was stuck over here, exactly over here. Okay, if I just zoom out. So these are some Dockers which we get only in GNS3. Okay, and what are these going to be? These are going to help us on our AAA, like Radius, TechAS, DNS, Python, or the network automation, and syslog. Okay, so when I'm doing a lab demonstrate these technique or these topology or these topics, uh, that is where I will be stuck on evng. I don't have any docker for that, and I'm not sure how can I demonstrate these few topics, or these few technologies on evng. Okay, over on gns it is very simple. We have some ready-made templates, so I'll tell you how what do you mean by ready-made template. If you go to gns3 marketplace, you have something called appliance. So if you go directly click on this appliance, you will get every ready-made templates. Okay, and these templates are helping us to demonstrate AAA servers. Okay, so let's say I want to have AAA concepts. I'm talking about some AAA. So I'll download this AAA. This will be a Docker with Linux base, and the features will be integrated. Okay, it's very easy for me to demonstrate radius, like what are the port, how the radius work, or what is the wireshark capture for these traffics, which I was not able to get on evng. Okay, so this is where I was stuck, and yes, it's your call if you want to drop those topics. Might be you can recreate other things are all good. Okay, routing, switching, ASA, firewall is all good. Only the services is a drawback in evng. Okay.
Okay.
No, I'm not using ACS. Okay, for AAA, I'm using the ready-made instance from uh, marketplace. So this is what I told you. Okay, AAA is out of industry now. Nowadays, we have Cisco ICE server, and ICE is not part of enterprises. It comes under security topics, but we don't have to have such complicated device to demonstrate AAA. Okay, AAA, to demonstrate the functionality of radius and TECAS, I can be based of this tiny Docker, just a 1 MB file size. Okay, I can demonstrate the lab. So I'll tell you how I do that, all those things. Yes, I can get it over on Pro, but what about you guys? You guys will be stuck then. Then you will say that I did something which you guys cannot do. So I just wanted to keep it neutral for everyone. Okay, not that I can do and you guys cannot do that. Okay, guys. So let me sign off. It's already 12:30 here in India. So we'll meet up in the next class. Next class, I will give all the recordings and the notes will also be put up. I'm also in a progress of giving individual access to each one of you, those who have enrolled. So just be tuned. It will take 4 days to get everything sorted up, and we should be good. Okay, so just don't get panic or don't lose your patience. So appreciate everyone's time and patience with handling these topics. Okay, so basically this happens in every course when you join. Okay, so 1 or 2 3 days it will take to settle it down. So that is what I am also expecting from you guys. Show us some patience. Okay, fine. So let's meet up in the next class. Have a wonderful day.
Sagar,
Yes, go ahead.
could you please share your email ID
Okay.
or contact number? I just messaged you.
Okay, so you want me to do it over here straight away? Okay.
Anything is fine.
Okay, so basically you can
send me your message on some private.
Yeah, but I don't know what is your WhatsApp number. So basically this is my email ID, and you can basically, okay, I just forgot 973. Okay, this is my WhatsApp number. So just reach out after the class. Okay. Fine, guys. Have a nice day. Take care, everyone.
Thanks.
Okay, see you. Okay.
Thank you.
Thank you.